Start.
Okay, today we will start Module 3, Embedded System Components. Let us go through the syllabus one. Module 3, 4 and 5 is taken from the textbook Shibu. Below you are seeing the author name Shibu KV, and in the textbook name is Introduction to Embedded Systems. So Module 3, 4, 5, all the three modules are present in this particular textbook. So now let us start with Module 3. Module 3 has got two chapters. Chapter 1, you are seeing there embedded system components versus general computing system, history of embedded systems, classification of embedded systems, applications, all these things comes in chapter 1. Next, core of embedded systems, including all types of processor, controller, and all the applications comes in chapter 2. So this is just a brief description about the syllabus of Module 3. So now let's go to the next slide. So now it's Introduction to Embedded System. What is an embedded system? So before going to the question, what is an embedded system, let us look around some of the applications that we are seeing every day. Let us see the examples there, like electronic toys, mobile handsets, washing machines, air conditioners, automotive control units, set-top box. If you take any of these examples, you can understand that it involves a mechanical component, electronics, and electrical sciences. So now let us come back to the definition. What is embedded system? So it is an electromechanical system designed to perform a specific function. So if you take any of these examples, like toys or washing machines, air conditioners, they are meant to perform a specific function. So that is what they are telling. It is mainly meant for performing a specific function, and it is a combination of both hardware and firmware. So hardware, all of you know, it is a hardware component. What is firmware? It is a software put on a chip. So this we will see in the lab. So in to generalize this, we can understand that you take any embedded system, it is meant for performing a specific application, like a washing machine meant for washing clothes, air conditioners to maintain the room temperature. So this is a brief summary of an embedded system. So now let us go to the next slide. So now here we are going to understand what is the difference between the embedded system and the general computing system. So now if you see the general purpose computing system, this we are already using it. Then how is it different from the embedded system? So now let us see the first example. So whatever, to start with the first point before starting, I want to tell you that general purpose computing system is nothing but our desktop systems, our laptops meant for performing general functions. It could be like if you take any you take your systems or laptops, you can execute your programs, you can listen music, you can watch movies, you can send mails. So this is a general purpose system. So how is that different from embedded system in the technical aspect? That we will go through one by one. What is the first difference? A system, general purpose computing system. So what is the first difference? A system, which is a combination of a generic hardware. So the hardwares are general because it has to support all the applications. And general purpose operating system. So even the operating systems are general purpose. You take Windows, or it supports various applications. Now in contrast, let us see the embedded system part. What is embedded system? A system is a combination of special purpose hardware and embedded operating system. Means it has got a special hardware. It is not a general hardware, it is special purpose hardware, and even the operating system is meant for embedded system. So this we will see in the fifth module in detail, how the operating systems are built for embedded systems. Now let's go to the second point. In the second point also he talks about the operating system. As I said earlier, it contains general purpose operating system, means that it is like Windows, like that. And here embedded system, it may or may not contain an operating system for functioning. Means if you take a simple applications like toys or traffic signals, it doesn't involve any operating system. But if you take washing machines, ovens, definitely it involves operating system. Let's go to the third difference. In the general purpose computing system, applications are alterable. Means if you want to install any app, you can install in the laptop or the desktop. And if you don't want, you can uninstall. So you have that flexibility in general purpose computing system. But in case of embedded system, we call that as firmware. I told earlier in the previous slide, it is nothing but the software embedded on a chip. So it is called as firmware. The firmware is not alterable. You cannot alter means end user cannot alter it. So whatever the programs that are written for ovens or washing machines, as a user you cannot alter, you can only use it. So this is the next difference. So let's go to the next difference of general purpose computing system. Coming to the performance aspect. In case of general purpose computing system, the performance we look into the speed, that is faster is better. Now let us go to the embedded system. Here, along with the speed, we also talk about the power requirements, memory usage. All these things come as a key deciding factors. Now let us go to the next difference. Less or not at all tailored towards the operating system. So as I said already, it is not tailored. So for different levels of power management means here it is a general purpose operating system, definitely the power consumption will be more. Now coming to the embedded system operating system, it is highly tailored, means if it is very complicated, then definitely it makes use of complicated operating system, and the power consumptions, everything will be more. If it is small, it takes less power. So this is the difference. Let's go to the next one. Next difference. Response requirements are not time critical in general purpose system, means while executing any program, if there is a delay in the output, you can still wait. That is not an issue. When you are downloading something, if it is taking time, you can still wait, not an issue. But in embedded systems also, some applications may not be critical. If you take toys or washing machines, it is not that critical. But if you're taking some critical systems, so I would like to take examples here like the defense or the satellite launching, all those applications. There also we make use of embedded systems, and there it is working in the critical situation. So definitely it has to work with the critical situation. So the timing matters a lot in such kind of applications. So now coming to the last difference, coming to general purpose system may not be deterministic in execution behavior. So it is a general purpose system, so the behavior is not specific. So accordingly, it will be behaving. Whatever the application you are going to use, the particular system gets adapted to that particular application. But if you take embedded systems, as I said earlier, it is actually specific in nature. The applications are specific in nature. Therefore, it is even the execution behavior will be specific in nature. So this is the difference between the embedded systems and the general purpose computing system. So now let's go to the next slide. Let's go to the next slide. What is the next slide talking about? It is a history of embedded systems. So here we just understand that even embedded system has evolved over years. So initially it was recognized by the Apollo guidance computer, and the next mass production was happened in Automatics E17 guidance computer. All these are the names of the oldest embedded systems, and it was these embedded systems were widely used in NASA applications in US. So it evolved from there. Initially they started working with satellite launching and defense sectors, and later it came to the society. So now let us classify the embedded systems. So classification of embedded systems is based on generation, based on complexity, based on deterministic behavior, and based on reasoning. So based on these, you can also classify. So we will see one by one. Few things are there, and few things are elaborated in the other module. So let us see what is there in this module. So we'll go to the next slide. So the classification based on generation. So here we are trying to classify the embedded system based on generation. So what is first generation system? So first generation systems are built around 8-bit microprocessor. This I have already told in the class. 8-bit microprocessor or a microcontroller, it is nothing but we are talking about the data line. If I'm telling it is 4-bit microcontroller, then it is that microcontroller has got only 4-bit data lines. Now let's go to the second generation computer. So things evolved. So in the second generation computer, the microcontrollers had 8 or 16 bits. Means the data bits were either 8 or 16 bits. Now let's go to the third generation computers. In the third generation computers, you're seeing it is increasing. The data lines are 16 to 32-bit. So it was widely used in application-specific instruction set computers like DSPs and application-specific integrated circuits. These things are widely used in the industries, manufacturing industries, application-specific integrated circuits. The entire thing will be embedded in one IC along with the microcontroller. Whatever is required, they will put it into one IC, and that becomes more application-specific. They're widely used in the manufacturing sector. Now coming to the fourth generation, embedded systems built around systems on chip reconfigurable processors. Here we are having one more option, that is it is not just you're putting everything on a chip, you can also reconfigure, and you can have multi-core processors. Means earlier we were using only one microcontroller, now you can embed it with several microcontrollers on one IC, just like your processor. So this, whatever we are talking, is about the embedded systems based on generation. So let's go to the next slide. So let's see how it is classified. Now the next classification is based on complexity and performance. So if you see, it is small scale. So the small scale, medium scale, and large scale. So if you see the small scale, it is mainly built around 8-bit processor. And where we can use this in small scale, definitely we can think of just toys or traffic signals, wherein the application is very, very its dimension or its requirement is very minimal, and there is no time criticality. So we can think of those applications. For those applications, it definitely works with 8-bit or 4-bit microcontrollers. And if you talk about medium scale, something much more than the small scale. So there are various applications that are built on medium scale. I can take an example of washing machines and ovens. It has got some operating systems, everything along with the processor. So this comes under medium scale. And if we talk about large scale, as such, we have already seen in the generations, definitely we are talking here about digital signal processors, application-specific integrated circuits, means widely used in the manufacturing sectors. The industries themselves, they use these kind of machines to manufacture the product. I hope you're getting it. Maybe the automobile industry, to manufacture car, they have their own system, an embedded system to manufacture different parts. So that type of applications we can think of application-specific integrated circuits. So now let's summarize in the next slide how it is, how the major applications, and some of them we have seen in our day-to-day life. Let us see what are the things that comes under this embedded system. If you see here, consumer electronics, camcorders, cameras, as you have already seen, household appliances. See, here also we are using embedded systems like smart TVs, DVD players, washing machines, refrigerators, home automation. Here you're seeing air conditioners, sprinklers, intruder detection alarms, CCTVs, and you're seeing all this every day. Automotive industries, like in the automobile sectors, also you're using anti-lock braking system, engine control, ignition systems. Telecom sectors, you're using telephones, telephone switches, all these things you're seeing. So let's see further in the next slide. We will see that we are also making even the printers, scanners, fax machines. In that also we are trying to embed the microcontrollers there, and the networking system. So routers, switches, hubs, firewalls, where the decision making is involved. All that also has got an embedded system, means it has got an embedded controller inside. Healthcare systems like scanners, EEG. EEG is mainly used to capture the brain signals. ECG, all of you know, it is mainly used to see the heart rate. And the next one, measurements and instrumentation. We are seeing in digital multimeters, CROs, logic analyzers, PLC systems. All these things you have already seen in the AD lab. Now coming to the next application, you're seeing the banking and retail, automatic teller machines, currency counters. This also you would have seen in banks. It also has got an embedded system inside that. And you have something like card readers, barcode readers, smart card readers, handheld devices, something like the handheld devices like conductors having their own handheld device. So all these things come under all these things are the applications of embedded systems.